Hey guys, I'm going to introduce you to adding and subtracting fractions. Our last two lessons have been over prime factorization, greatest common factor, and least common multiple. And we're going to be using all of those things here. Majority of the time we're going to be using least common multiple. Okay? There are a lot of examples on the board. I'm going to walk you through every single one of them because there are multiple different ways to subtract fractions. The first thing we need to talk about are the rules when we're subtracting fractions. The first rule is that you must have a common denominator. The number at the bottom of the fraction of all the fractions you're adding or subtracting must be the same. For example, 3/5 plus 1/5. The denominators are both 5, so we can either add or subtract those numbers. So that's a must. You have to have a common denominator before you add and subtract fractions. Okay? The second piece of information you need to know is they must be improper fractions. Okay? This is a mixed number, 1 2/3. Okay? We have to change that to 5/3. And to change that, all you do is simply multiply 3 times 1 and add 2 to it, and that makes 5, and you keep the denominator the same. Okay, so you must change your mixed numbers into improper fractions before you can add or subtract fractions. Alright? Now, once we start adding, those two things have to be done before you can add or subtract. Now, when we start adding, these are the 3 rules you need to follow. Or subtracting. Either way, you must keep the denominator the same, okay? So you found a common denominator, you've moved it to an improper fraction. Whenever you're adding or subtracting, you don't add the denominators. The denominator must stay the same, okay? So, for example, in this example right here, whenever we're adding these two fractions, your 5 is going to stay your denominator in your answer, okay? Now, the next piece of information, you use your integer rules for the numerator. Okay, so whether you're adding or subtracting, you still use your integer rules as if that is just 2 integers that you're adding together or subtracting. So we need to remember leave change opposite is very important. When you're adding a positive and negative, what rules you need to follow. And so whenever you're adding 2 numbers that are positive and negative, you subtract the 2 numbers and take the sign of the bigger number. That comes into play here. So those integer rules we need to be fresh on if you need to look back in your notes and look at over those to help you remember to be successful on fractions. You might want to do that. And then the last piece of information, you've already kept your denominator the same. You've added the top or subtracted the top like normal. And then what you need to do is reduce your answer and write it as a mixed number. Okay? So we want our fraction to be as reduced as possible, and if it's improper, we want to write it as a mixed number. Alright? So let's start walking through these examples. Our first example is 3/7 plus 5/7. Okay? Do we already have a common denominator? Yes. That's great. Are they improper fractions? Yes, that's great. So what we need to do is keep the denominator the same, so our 7 stays the same. Then we use integer rules for the numerator. 3 plus 5 equals 8. So we have 8/7 as my fraction. Now, this fraction is not written. It's reduced already, but it's not written as a mixed number. So to write this as a mixed number, we say 7 goes into 8 one time. So that's our whole number out here. And how many are left over when we do that division? There's 1 left over. So our fraction out here is going to be 1/7. So 8/7 is the same thing as saying 1 and 1/7. So the answer to this problem is 1 and 1/7. Okay? Example 2. We have a fraction 5/8 plus another fraction -7/8. Okay? First thing we ask ourselves, do we have a common denominator? Absolutely. They're both 8. So we can just use that. Are they improper fractions? Yes, they already are. We're good. We keep the denominator the same. Then we use integer rules for the numerator, 5 plus a -7. So we have 5 plus a -7. We take the difference of those two, which is 2. And -7 is larger, so we take that sign. So my answer is -2/8. Now, is that reduced or written as a mixed number? It's not reduced. 2 and 8 can be divided by 2. Both those numbers can be divided by 2. So 2 divided by 2 is 1, and 8 divided by 2 is 4. So our reduced answer is -1/4. Okay? Our next example, 6 and 5/8 plus 1 and 1/8. Okay? What we want to look at here first are the improper fractions. That's what I'm going to do first, is change them to mixed numbers. Okay? So what we're going to do is 8 times 6 plus 5 is 53. Keep the denominator. 8 times 1 plus 1 is 9. Keep the denominator. So then we look and say, hey, do we have common denominators? We do. So we're going to use our denominator, keep it the same, and we are going to use integer rules for the numerator. 53 plus 9 is 62. Alright, we want to reduce our answer and write as a mixed number. Okay, first I like to write as a mixed number because I'm dealing with some big numbers first. So 8 goes into 62 7 times, and there's 6 left over. So our mixed number is 7 and 6/8. 6/8, from divisibility rules, I see that they're both even, so I know 2 is going to go into them. So I reduce those by 2, and we have 7 and 3/4. Okay? Alright, our fourth example, 9/20 minus 13/20. Okay? We already see that 9/20 is smaller than 13/20, so we know our answer is going to end up being a negative number. Okay? Are our denominators the same? Common? Yes. Okay, so we're going to leave it 20. Now, this is the first time we've had a subtraction, and I want to make sure we remember our rule, leave, change, opposite, or same, change, opposite. I know some of y'all say it differently. So we're going to do 9 plus a negative 13 here. 9 plus a negative 13. Okay, so when we're adding two numbers that have opposite operations, so 9 and negative 13, we're going to subtract them, we get 4. 13 is larger, so we keep a negative. And so we have -4/20. Okay, that we look and say, is it reduced or written as a mixed number? It's not reduced. They're both even, and they both have 4 that goes into them. Okay, so 4 goes into 4 once, 4 goes into 25 times, so this answer is -1/5. Alrighty. Stop and pause and go back and